In this video, we are going to learn how to solve exponential equations with any base. Exponential equations have many practical uses, so it's important for advanced math students to know how to solve them. Let's start with a quick review of how to solve exponential equations with special bases. So here we have bases of 3 and 27. We can rewrite both of those using base 3. So we'll leave the left side alone. We'll rewrite 27 as 3 to the third power, and we still have that power of 2. And we'll just use our exponent properties. And we multiply those exponents, so 3 to the 6th power. Now we have two equations, or two expressions that are equal to each other, and the bases are the same, so the exponents must be the same. So we have y plus 5 equals 6. And we can subtract 5 on both sides and get y equals 1. Now we can't rewrite 671 as a power of 10, but we can rewrite this with logarithms and use our scientific calculator to help us solve for b. So here the base is 10, so it'll be log base 10 of 671, and that equals the exponent. Now log base 10 is the common log, and so we actually don't need to write the 10 there. So let me just rewrite this as log of 671. That equals negative 6b. I can go to my scientific calculator and figure out what the log of 671 equals. I'm going to use lots of decimal places because I'm not at the answer yet. So how about 2.8267? And all that's left to do is divide both sides by negative 6. And when I do that on the calculator, we get negative 0.47. We can also use our scientific calculators when we're using base e. So before I rewrite this using logarithms, I'm going to divide both sides by 672, negative 672. And when I do that on a calculator, I get 0.00744. I'm using lots of decimal places because I'm not at my answer yet. And now this is log base e of 0.00744 is equal to the exponent. Now, when we have base e, we don't write it this way. We use the natural log. So ln of 0.00744 equals negative 3z. So when you have log base e, well, that's the natural log, so we just use ln. And we can do this on our calculator. How about the natural log of 0.00744. Not quite at the answer yet, so I'm going to use lots of decimal places, negative 4.9009. And then just divide both sides by negative 3. And when I do that and round to the nearest hundredths place, I get 1.63. Okay, now to the main event, solving exponential equations with any base. There are different ways to do this. Here I'm going to rewrite the exponential equations using logarithms, and then use the change of base formula. So to solve 7 to the m plus 7 power equal to 6, I'm going to rewrite this with logarithms. So it's log base 7 of 6 is equal to the exponent. Now, most scientific calculators don't have a log base 7 button, So we're going to use the change of base formula to rewrite the left side of this equation. Log base 7 of 6 is equal to log base 10 of 6 over log base 10 of 7. So all I did there is I rewrote the left side using the change of base formula. And we didn't have to choose base 10. We could have used any base we wanted to, but my scientific calculator has a log base 10 button, so I'm going to use that. And remember, when we use base 10, we usually don't write the 10. And this equals m plus 7. All right, so over to this scientific calculator. All right, so in the numerator, I have log of 6. In the denominator, I have log of 7. And I'll use lots of decimal places here, so 0.9208, rounding that 7 up to an 8. All right, so log base 10 of 6 and log base 10 of 7, or divided by log base 10 of 7, that equals 0.9208. That equals m plus 7. So then we just subtract 7 on both sides and get m equals negative 6.0. Let's try another one like that. So this equation's all set to be rewritten with logarithms. So I have log base 3 of 11 is equal to the exponent. I'm going to rewrite the left side using the change of base formula. That just equals log base 10 of 11 divided by log base 10 of 3. And that will equal z minus 9. So that's just using the change of base formula. Okay, now it's time to go to the scientific calculator to figure out what log 11 divided by log of 3 is. And using lots of decimal places, I'll do 2.1827. I'll just add 9 to both sides and get z equals 11.18. Now the only difference here is that I need to do a little bit of algebra before I rewrite these equations using logarithms. So the first step here will be to divide both sides by 9. And when I do that on a calculator, I'll use lots of decimal places, and I get 57.8889, just dividing those two numbers. Now I'm ready to rewrite this equation using logarithms. So I have log base 2 of 57.8889, and that is equal to the exponent. Now, most scientific calculators don't have a base 2 log button, so let's go ahead and calculate this just using the change of base formula. Very handy that we're allowed to do that. And I'll go to the scientific calculator to calculate the log of 57.8889 divided by the log of 2. And using lots of decimal places, I have 5.8552. And we just need to divide both sides by 5 and get y equals 1.17. Here's one last one. Before we rewrite this using logarithms, let's go ahead and divide both sides by 3. Lots of decimal places because we're not at the answer yet. Now I'll rewrite this exponential equation using logarithms. So I have log base 2 of 122.3333, and that equals the exponent. We don't have a base 2 logarithm button on most scientific calculators, so let's go ahead and real quickly rewrite this using the change of base formula. So we've got the log base 10 of 122.3333 over log base 10 of 2. And using lots of decimal places, I have 6.9347. And we'll just divide both sides by 6. And when we do that, we get 1.16. I hope these examples have helped you learn how to solve exponential equations with any base. This is Mr. Ela, signing off.